Okay, here are the notes for Unit 7.2, Conservation of Work and Energy. The definition of energy, I usually define it as the ability to do work. So it's a situation where you have stored some work and you're able to do that work later. There are lots more, there are more nuances to it as you study more physics and engineering courses, but for now, the ability to do work will suit us quite nicely. A big idea, two big ideas, is that energy and work are equivalent. So, for example, if I had a spring lying on its side, if I exerted a force on the spring to stretch it out, I would do work. The distance that I'll draw it like this. Oops. Here's my stretched out spring. The distance that I stretch that spring times the force, that's what work is. Work is force times distance. And now when I'm holding, let's say that I'm holding it with my hand. That's my hand. Okay, I'm holding the spring there in place. I'm storing energy, and if I were to let that spring go, it would move. Something would happen. And so that work that I did isn't lost. It's converted into a different form. It's converted into elastic, what we would call elastic potential energy. So I'm going to make a little chart down here of types of energy. And the first one that we learned about in the last section is elastic potential energy. And it's stored, this is stored in, it could be stored in a spring, but be careful here because there are lots of items in the world with elasticity. For example, a rubber band, and even objects that we don't think about as having elasticity do. Go watch a video of a slow motion cymbal hit. And you'll see that a drum cymbal has tremendous elasticity. So anyway, you can find this hiding where you might not expect to see it. Okay, and elastic potential energy we learned how to calculate in the last section. In this section, we're not going to talk about the calculations. We're just going to talk about the ideas. So we're going to really try to cement those ideas. The next big idea was work. And work is force times distance. I'll write out the words. So the object has to move in order for work to be done. Okay, going back to this example where I stretched a spring, and then I hold it, and now maybe I let it go, and the spring moves. That energy of motion is called kinetic energy. So any object that is moving on its own has kinetic energy. Another type of energy that we have, what's another way that I could give an object kinetic energy? We studied this earlier in the class. If I take a ball, oops, I didn't mean to make it bigger. I just wanted to move it. If I take a ball and I lift it, when I lift the ball, I really lifted it. If I lift the ball, I can also drop the ball. And when the ball falls, it gains this kinetic energy. It gains this energy of motion. Lifting the ball gives it something called gravitational potential energy. Anytime I take an object and put it on a high shelf or lift it, it has the potential to fall down. So this is energy due to height or position. Okay, Then finally, what we're going to look at is something called dissipated energy. And dissipated energy is what happens when energy is transferred from the object to the environment. So let's suppose, for example, that what I drop is not a ball, but it's a blob of clay. And I start, and the object's, the blob of clay has gravitational potential energy, which actually I'm going to call E grav. Then the clay falls, and right before it hits the ground, its gravitational potential energy has turned into kinetic energy. But then let's say the clay hits the ground and it smooshes. Smush. When the clay hits the ground and smooshes, where did all of the energy go? Well, we would call it dissipated energy. It goes into sound, it goes into heat, it goes into deforming or smushing the clay itself. So the big idea here is that energy is neither created nor destroyed, it's changing form. And what we're going to do is a series of practice problems where we just think through what are the types of energy in the scenarios, and how is energy changing form between these different forms. I'm going to use shorthand. So elastic potential energy, I'm going to call E, EL. Work, I'm going to call W. Kinetic energy, I'll call K. Gravitational potential energy, I'm going to call EG or E grav. And dissipated energy, I'm going to call E dis. Okay, so I'm going to keep those in mind as I do these practice problems. In each situation, complete the energy pies showing the type of energies present. Question 1. We kind of just talked about this one. A ball is held above the ground, and then it's dropped so it falls straight down. Okay, so what I'm going to do is number 1, 2, 3, 1, 2, 3. I'm going to draw a pie chart, an energy pie chart for each position. The idea is the total amount of energy is the same. That's what the pie chart is trying to say, but the form changes. So at the top here, this object has height. It has energy due to position. And that's gravitational potential energy. So I'm going to say that the object starts with entirely EG. Okay, then I'm going to look at position 2. Now at position 2, it's not quite halfway down, so it hasn't lost all of its EG. It still has a lot of EG. The other kind of energy that the object has is kinetic. How do I know it has kinetic? Because it's moving. At this position, the object has some EG and some kinetic. It has a little bit more EG than kinetic, and I know that because it's more than halfway up. And then the instant before it hits the ground at position 3, all of that gravitational potential energy has been converted into kinetic energy. The total amount of energy is the same. So if the object started with 10 joules of energy, it's got 10 joules of energy in each pie. It's just that the amount has, or I'm sorry, the type of energy has changed. Okay, let's look at this number 2. A wind-up toy is wound up and then walks across the table and comes to a stop. Well, first of all, to make a wind-up toy work, you have to do work. You have to wind it up. So first work is done, okay? But then the instant that I put it on the table, this arrow indicates that it's moving, so it's going to be all kinetic energy. Actually, I take that back. It's going to be kinetic energy, but there's also a spring coil inside that's storing elastic potential energy. So this object has some of both. It has elastic potential energy and it has kinetic energy. Now what happens as it walks is some of the energy is dissipated. And I'd have to see the speed of the object. Here it looks like the speed is slower in position 2. So the kinetic is less, and the elastic is less too, because energy has been dissipated. And the dissipated energy goes to sound and heat. And then finally, at position 3, the object has stopped moving and the spring is unwound. So this is all EDIS. All of the energy has been dissipated to the environment, away from the wind-up toy. Let's do a couple more. A super ball is dropped and bounces up and down. Do a pie chart for each position of the ball. So I'm going to number these just so I don't get lost with what I'm doing. So this object is going to start with all gravitational potential energy. I actually, again, have to do work to lift the object to this position. But then it has gravitational potential energy. When it actually has hit the ground at number 2 and it's smushed, the ball itself does store some elastic potential energy in the ball itself. Let's see, but some of the energy has been dissipated. Actually, I should make this a little different. Oops. How much has been dissipated? Well, I know it's way less than half because look how high the ball comes up at number 3. At number 3, we have the same amount of energy has been dissipated, but that elastic potential energy has now been converted back into EG, gravitational potential energy. Then at position 4, a little bit more, every time it hits the ground, a little bit more energy is dissipated. And the smushing of the ball, this is an elastic ball, so the smushing of it is basically storing energy like the ball itself is a spring. And then finally at position 5, we've dissipated about half the energy because it's going about half its original height, and this is gravitational potential energy. Okay, one more example. An object rests on a coiled spring and then is launched upward. So when the spring is coiled or pushed on, elastic potential energy is stored in the spring. I can see in 3 that the object is going to get to its maximum height. That's gravitational potential energy. And in the middle, it's got a mix. It's got some gravitational potential energy and some kinetic energy. All right, that's the end of this note section. I will make a video with some more